Prior to discussing the announcement, it is essential to comprehend what particle accelerators are. The Big CERN's Hadron Collider, LHC, a 17-kilometer-long superconducting magnet ring, is the largest and most powerful particle accelerator in the world. It symbolizes the highest level of human scientific accomplishment, powerful enough to recreate the conditions that existed at the beginning of the universe. But could this apparatus be used to unlock the secrets of the universe? The key may lie in something much more unsettling. CERN, established in 1954, is one of the most reputable research institutions with 23 member nations and thousands of scientists. It serves as a hub for collaboration, and CER's flagship innovation is the LHC, yet is only one component of an extensive system of accelerators and experiments. Envision a racetrack, not for horses, but for subatomic particles racing against time. The LHC accelerates protons in a vacuum to nearly the speed of light, sending them into head-on collisions that simulate the energy levels of the Big Bang. These collisions create temperatures millions of times hotter than the sun's core. Thousands of magnets facilitate the proton's journey, while advanced cooling systems maintain the magnets at temperatures colder than outer space. The LHC's beams are directed to collide in 4 distinct areas around the accelerator ring, where 4 major particle detectors are located: LHCb, Atlas, CMS, and Alice. Each serves a unique role in investigating various aspects of particle physics. These detectors function like enormous cameras capturing images of the collisions. Scientists then analyze this data to find evidence of elusive phenomena, such as the Higgs boson, also known as the God particle, which provides insight into the fundamental building blocks of the universe. By studying the microcosm, we gain insights into the macrocosm. But every answer raises new questions, and each discovery introduces new challenges. The LHC is more than just a scientific tool. It exemplifies human curiosity, innovation, and our unyielding desire to understand the essential forces that shape our universe. Yet such ambition also demands responsibility. We must consider the moral and existential implications. The potential dangers of probing the unknown. Could our quest for understanding accidentally unleash forces we cannot control? In the halls of CERN, where the limits of human comprehension are constantly being pushed, a revelation emerged, one that even the most well-intentioned researchers did not foresee. Brian Cox, a former CERN researcher and renowned particle physicist, recently made a statement that has since become etched into scientific history. His words were both fascinating and terrifying. He described the goal of the Large Hadron Collider at CERN with haunting clarity: to recreate a miniature version of the Big Bang. Yes, a scaled-down replica of the very event that created our universe. Cox went on to describe the ramifications of this objective, emphasizing the extraordinary capabilities of the LHC. This includes its potential to unlock the secrets of the Higgs boson and a mysterious substance known as dark matter, a crucial component of the cosmos. Imagine holding the power of the universe in your hands, the power to conjure the very essence of existence. It's an alluring possibility. But this mini Big Bang is not merely theoretical. It's an observable reality at the LCC. The temperatures, pressures, and raw energy at play simulate the conditions of the universe's infancy, a glimpse into the moment existence began. Yet, with great power comes great responsibility. What if something went wrong? In fact, something did go wrong once. In 1978, Russian physicist Anatoly Bugorsky experienced a catastrophic accident that forever altered his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protovino, Russia, his head accidentally entered the direct path of a proton beam. The beam, with a force beyond human comprehension, entered the back of his head and exited through his nose. Bugorsky saw a flash brighter than 1,000 suns, but astonishingly, he felt no pain. The beam burned a trail of destruction through bone and tissue. Yet he remained conscious, even attempting to walk to the clinic for treatment. The aftermath was both fascinating and horrifying. Localized tissue death, partial facial and ear paralysis, and loss of hearing. But his intellect remained intact. And he continued his scientific work. This incident is not merely a personal tragedy, it's a cautionary tale. It highlights the enormous power and potential danger of particle accelerators. Accelerators like the LHC must not be underestimated. They carry the risk of unintended reactions, manipulations of space and time that are not science fiction, but legitimate concerns within the scientific community. One of the most troubling possibilities is the creation of a miniature black hole, a region of space-time where gravity is so strong that not even light can escape. Could the LHC create such an entity, even at a microscopic scale? The very idea is shocking, both to the public and to many professionals. Such a black hole, if stable, could theoretically expand uncontrollably, consuming the Earth from within. CERN scientists have asserted that any black holes created would be unstable and would evaporate almost instantly. But the very possibility has sparked fear and awe at the tremendous power humanity now holds. To understand how the LHC might form a black hole, one must understand the fundamentals of particle accelerators. When protons collide near the speed of light, they release an enormous amount of energy, enough to alter the fabric of space-time. Imagine a stretched trampoline. Place a heavy object in the center and the fabric warps. Sufficiently massive object could cause a depression so deep that surrounding material falls into it. That's a rough analogy for what might happen in the quantum world, in quantum physics. The universe is not only beautiful, but bizarre. Some theories suggest that additional dimensions may be hidden within our own. If they exist, collisions at the LHC could tap into them, creating a gravitational funnel, a tiny black hole. This motion of particles has attracted the attention of leading scientists. In his book, the late Stephen Hawking warned of a scenario where the Higgs boson could become unstable at very high energy levels. This could lead to a catastrophic vacuum decay, threatening not just Earth, but the entire universe. British cosmologist Sir Martin Rees also expressed concern. In his book on humanity's future, he explored the risks of experiments at CERN and similar facilities. These warnings carried an existential undertone. He described a worst-case scenario, a disastrous experiment triggering vacuum instability, a phase shift rippling through space-time, destroying the universe. Rees didn't believe this outcome was likely, but he still assigned it a small probability and argued that even a minuscule chance of catastrophe warrants extreme caution. Scientists at CERN have conducted simulations and tested the theories. Brian Cox himself acknowledged the importance of responsible research. Despite public concerns, he stressed that extensive safety measures are in place. Cox emphasized that the energies involved are within the range of natural cosmic collisions the Earth already endures. The likelihood of creating a stable black hole is exceedingly low, and if one were created, it would be so fragile and small that it would evaporate instantly via a phenomenon known as Hawking radiation. A brief glimpse into the void then. Nothing. Still, speculation continues. Some claim the LHC may open a portal to another dimension or universe. While this idea is largely rejected by the scientific community, it has captured the imagination of the public and the media, evolving into modern folklore. Could we, by accident, activate forces we can't control? The idea of opening a door to hell has sparked sensationalism across platforms. But what does this really mean in a scientific context? Parallel dimensions are not a new concept in string theory. And while there's no empirical evidence for them yet, the LHC remains one of our best tools to explore such exotic physics. The theory of a single theory of everything suggests that, in addition to the usual 3 dimensions of space and 1 of time, there may be 2 additional dimensions. These could be trimmed down or concealed from view, But they could, in theory, be accessed or exposed in extreme circumstances. Imagine the LHC as a cosmic key, releasing locks on closed doors since the beginning of time. When protons collide with unimaginable energies, they could theoretically unearth rip holes or create ripples in the fabric of space-time, establishing temporary entrances or ways into these dark places. Even though a lot of this still lies within the realm of science fiction, it is hard to ignore the heaviness of possibility. At its core, the topic of this discussion is, what are the responsibilities if we interfere with forces that have the potential to change the actual fabric of reality? With the LHC's capacity to examine the deepest realms of the universe, ought we to be concerned about the potential outcomes? Along with other scientists, Brian Cox continues to investigate the universe's mysteries. The pursuit is certain in one respect. The pursuit of knowledge comes with risks. Uncovering the unknown involves many dangers, both seen and unseen. The story of the LHC is not simply a story of cutting-edge science. It tells the story of humanity's insatiable need for understanding. Through each experiment, every new thing discovered in the universe becomes increasingly intricate and surprising. But the question remains open. When we discover the most obscure aspects of the universe, are we ready for the consequences, or do we intend to reject them? We are now standing at the brink, looking into the unknown from the edge of the universe, a universe that may not fully satisfy our need to control or comprehend it. The response to that question, which will be asked in the future, is filled with both danger and promise. As we approach the point of discovery, we must consider whether we are truly prepared to face whatever we might unleash as we reflect on the future of the LHC and its potential dangers and benefits. It is important to acknowledge the larger context of our scientific endeavor. The Large Hadron Collider is more than just an instrument built to answer questions about particle physics. It exemplifies the core of human exploration. Since the beginning of civilization, we have endeavored to comprehend our surroundings. Philosophers from ancient Greece, like Aristotle, attempted to unravel the mysteries of the universe using reason and observation. Thousands of years later, the Renaissance gave birth to modern science with figures like Newton and Galileo, transforming our understanding of the world. The LHC is the most recent and powerful instrument in our ongoing quest to discover the universe's mysteries. But all of this investigation carries immense responsibility. By delving into the most nuanced aspects of nature, as we challenge its boundaries through science, we are also testing the limitations of what we can control. The potential to gain insight into dark matter, antimatter, and the very essence of reality is incredibly enticing. Yet each step into this unknown must be taken with caution. Our understanding of physics remains incomplete, and that incompleteness carries the possibility of omission or misunderstanding. The implications of a particle accelerator could result in unanticipated events. The notion of creating black holes, for instance, has captivated the public's imagination. However, the scientific community understands the complexities involved. Most scientists at CERN are confident that the accelerator will not trigger any catastrophic event. They rely heavily on detailed modeling and theoretical frameworks to ensure the safety of these experiments. For example, string theory suggests that very small black holes could be produced, but they would quickly degrade due to quantum effects. Even if one were produced, it would have an infinitely short lifespan, vaporizing almost immediately. Still, despite these assurances, there are those who argue that we are unable to anticipate every potential outcome. The LHC operates near the edge of current scientific understanding. While its work is based on established theories, it is also establishing conditions for new inquiries and controversies. The risk of creating something entirely unanticipated, something that doesn't fit into our existing models, is very real. Numerous thought experiments from science fiction have suggested that tapping into unknown forces could have far-reaching consequences. Some critics are concerned that society is so preoccupied with the pursuit of knowledge that we might not fully comprehend the repercussions of our actions. This is part of a growing philosophical debate. Is humanity's desire for advancement and knowledge bringing us dangerously close to forces we cannot control? Some argue that we ought to adopt a more cautious approach, focusing on immediate benefits to society rather than pursuing lofty experimental goals that could endanger the world. On the other hand, many believe that science has intrinsic value. Despite potential dangers, they argue that humans must confront ambiguity to truly advance knowledge. This delicate balance between scientific prudence and curiosity is not new. Similar questions were raised during the development of atomic power. In the 20th century, the potential for nuclear energy to change the world was undeniable, but so were the dangers of radiation and nuclear weapons. Despite those worries, humanity's determination to explore did not stall. Likewise, the findings of LHC research could lead to innovations that transform not just physics, but the nature of existence itself. The potential of such research is also worth examining through an ethical lens. The LHC's research is carried out in the spirit of discovery alone justify the dangers associated with each experiment. Novel technologies and new methods are being developed, many of which have uses beyond physics. The knowledge gained may lead to breakthroughs in fields ranging from medicine to materials science. With such potential, and with unforeseen implications looming, it is essential for scientists to engage in ongoing public dialogue. Transparency from policymakers. It's also crucial to ensure that the benefits of research outweigh any risks posed. The LHC is more than a scientific experiment, it is a symbol of humanity's persistent drive to break new ground. Whether we are truly prepared to face the repercussions of these experiments remains to be seen. For now, it is only by being guided by a moral and responsible approach to scientific advancement, and by holding to the belief that the search for knowledge can lead to a deeper comprehension of the universe while safeguarding our future that we can move forward.